Hello, going through PreCalc 12.2 worksheet using the limit laws and the special limits, dealing with sums, differences, products, quotients, powers, roots, and then of course some of the special limits here. So number one here, we have some information here. We have three limits defined, and they have the same approach value. And then over here we've got the laws that we'll use here. So again, we're going to use direct substitution. And again, this limit of a sum can be broken into a sum of limits. So I'm going to take the f of x limit, -3, plus the h of x limit, 8. Add them together and I get 5, and final answer. Over here I've got a limit of a power, so I'm going to take the f of x limit value, square it, and I'm going to get 9. Again, that was law 6 there. This one we're going to take, this is a limit of a root, so I'm going to take the limit of h, 8, and then I'm going to cube root it, which comes out to be 2. Over here we have a limit of a quotient. So the limit of, as x approaches a of 1 is 1, using our special limit number 1. And then the f of x is -3. As long as we don't have a 0 in the denominator, we're in good shape. Moving on here, we have a limit of a quotient. So I'm going to take the f of x limit value and h of x. And again, that one is all done. Over here, g of x limit value is 0. And again, applying the number fifth limit law, and I'm going to go ahead and get here, and that comes out to be 0. 0 in the numerator is okay. G is the f of x limit value over the g of x. Oh, we got a problem here. Can't divide by 0, so this one does not exist. Can't do that. And then this last one here, we have a limit of a constant multiple. So I'm going to take 2 times the f of x's limit value and then apply the quotient with the difference limit law. So I'm going to get 8 minus -3, double sign change there. So I get -6 on top and 11 in the bottom, and we are all good there. So again, just kind of practicing a combination of using the limit laws with using the special limits. The next three, a little more documentation of our steps. So again, we're supposed to evaluate the limit and justify each step by indicating the appropriate limit law or laws. And again, we're going to use the number system here instead of writing out their name here. So the first thing I'm going to do is say, hey, I got the limit as x approaches 4 of 5x squared minus the limit of 2x as x approaches 4, and then plus the limit of 3 as x approaches 4. And I used laws 1 and 2 there. Okay, I'm going to go ahead and deal with these constants here. So I'm going to write this as 5 times the limit of x squared as x approaches 4 minus 2 times the limit of x as x approaches 4. And this one is going to stay the same. Not much action there here. And again, I used law, and that's going to be law 3. Okay. Now I'm going to deal with this power. So I have 5 times the limit of x as x approaches 4 squared, and then these last ones kind of stay the same. So I'm just going to rewrite those. And I used a law of the limit of a power. Okay, so that's law 6. And then now I can do some direct substitution using special limits here. So I'm going to go ahead here. I'm going to get 5 times the limit of x will just be 4 squared using the special limit number 2. Likewise here. And over here, I'm going to have the limit of a constant will just be the constant, and that's going to be special limit 1. So that's just going to be 3. So I use the special limit number 2. I used it twice. I'm going to mark it twice here, and number 1. And now I simplify here. So I get 5 times 16 minus 8 plus 3 equals 80 minus 8 plus 3 gives me 75. Okay, so you see how that kind of goes. Wasn't too bad. Next one here, first thing I'm going to do is do a quotient law. The limit as x approaches -1 of x minus 2 and divided by, or the limit as x approaches -1 of x squared for x plus 3. Okay, so that I use law of the quotient 5. Okay, now I'm going to split these up here, so I'm going to use some square brackets here. I got the limit of x as x approaches -1 minus the limit of 2 as x approaches -1 divided by, and again I'm going to do the same here. I'm going to get the limit of x squared as x approaches -1 plus the limit of 4x as x approaches -1 plus the limit of 3 as x approaches -1. And again, that were laws 1 and 2. Okay. Now this first one is kind of ready to simplify, but I got a little bit of work left on the quotient. And so I'm just going to rewrite these first ones here. Well, I'm going to do a combination of the power and the constant multiple here. So I'm going to get the limit of x as x approaches -1 squared. I'm going to bring out the 4 as x approaches -1. And then I get the limit of 3 as x approaches -1. And again, I did laws. I did the power, so laws 4, and I did the constant multiple 3. Okay. Now I can go ahead now and do some special limits now. So here the limit of x as x approaches -1 is -1 minus 2 here. Okay. Those were special limits. I did special limit 2 at 1 so far. divide by the squaring of x, which would be negative 1 squared, plus 4 times negative 1 plus 3. Okay, so I use the 3. Then I did the 2. And the last one I did 1. Okay, so now I end up with negative 3 over, this is 1 minus 4 plus 3. And oh boy, we get 0. Okay, so if that's the case, then we're going to go ahead and get, that's number 5. I was supposed to get 4. Oh, that's a minus 3 here. This was a minus 3. Whoops, let me kind of fix that all the way through here. This was supposed to be minus, this is 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 supposed to be minus. And so that's going to give me negative 6. Okay, which then equals 1/2. Sorry about that. Okay, moving on to number 3 here. Again, we got a product here, so I'm going to rewrite it as a limit as t approaches negative 2 of t squared minus 1 divided by, times, excuse me, the limit as t approaches negative 2 of t plus 1 to the 9th. And I used law, the product, law 4. Okay, now I'm going to go ahead and split these up a little bit here. So this one here, I'm going to get the limit of t squared as t approaches negative 2 minus the limit of 1 as t approaches negative 2 times, I'm going to do the power, so I'm going to say the limit of, with t approaching negative 1, of t plus 1 to the 9th, not the 2nd. Okay, so again, this is multiply here. And here I use laws. I use the difference law, so laws 2. And I use the power, so I use 2 and 6. Okay. I'm going to use the power law again here, so I'm going to get the limit as t approaches negative 2 of t squared minus the limit of 1 as t approaches negative 2. Okay, and then times, I'm going to go ahead and split up this t plus 1 here. So again, I'm going to get a limit as t approaches negative 1 of t plus the limit of 1 as t approaches negative 1, all raised to the 9th. Okay, so now here I use laws 6 for the power, and then I use the sum, so that's laws 6 and 1. Now I believe I can go ahead and start simplifying here. So in my first one here, I'm going to get negative 2 minus 1 Okay, looking at the okay. And then over here, I'm going to get negative 2 plus 1 to the 9th. Okay. So, and again, this is multiply, so I did the special limits. I did 1. I did 2. Okay. And so here I get negative 3 times this is negative 1 to the, and so that should give me positive 3 for the final answer. Okay, now let me just double check. Oh, this is negative 2. These are all negative 2s. Oh, I kind of changed that here. Okay, here, so we have that. Plus 1 to the 9th. And over here, oh, I forgot the squaring here. Sorry about this here. So this was squared. So this is comes out to be positive 3. So I end up with negative 3. Okay, so yeah, I forgot that squaring here. Okay, moving on here. Evaluate the limit here. We do not have to give the step. This one, we have to be careful. We try to do our friendly factoring first. So this can be written as x minus 2, x plus 3 in the top. This cancels. Okay. So for number 9, we get equals 2 plus 3. So we get 5. Okay. Over here, again, let's factor the top. X minus 3, x plus 2. We do that, so we get 2 minus 3 when we substitute that in with direct substitution, and we get negative 1. Okay. And when we take a look at that, that doesn't seem right. Oh, I see the deal here. We didn't have the issue here. Remember here, if I plug in 2 in there, I'll get 0. If I plug 2 in here, I'm good. So I'm going to get 4 squared minus 2 plus 6 over 4 plus, oh, excuse me, 2 plus 2. So on the top, I get 16 minus 2 plus 6. Bottom, I get 4. Here I get 20 divided by 4. Oh, this is a 2. What the heck? So this is going to be 8 over 4, which equals 2. So, okay, sorry about that. Now, if I plug in negative 3 in the bottom here, I'm not sure what I'm going to get, so I'm going to go ahead here and factor the top is going to be x or t plus 3, t minus 3. And the bottom here, I'm going to get 2t t plus 3 plus 1. If I plug in negative 3 in there, I will get a 0, so I need to go ahead here and cancel these pieces here. So now I'm going to take this and plug it in there, so I get negative 3 minus 3 in the top for number 13. In the bottom here, I'm going to get 2 times negative 3 plus 1. That gives me negative 6 over negative 5, which equals 6/5 for this one here. And that's number 13. Okay. Keep going here. Let's keep her going. Evaluate the limit of this exists here, so I'm going to have to simplify. This is like the example in Ms. Steele's notes here. So I'm going to get the limit as h approaches 0. H here, when I cube this out, remember when I cube something out, it's kind of doing this. Okay, so if I go ahead and do these two first, I get 4 plus 4h plus h squared. And then I still have this 2 plus h. Now if I go ahead and distribute, so I take the 2 and the 2 and the 2, I get 8 plus 8h plus 2h squared plus, if I distribute this, I get 4h plus 4h squared plus h cubed. And then all together, I'm going to write this in descending order. I get h cubed. That's gone. I get plus 6 h squared. These guys are gone. I get plus 12h. These guys are gone. And I get plus 8. So I get that. Plus I had that minus 8 at the end too. And that's important because if I would have plugged in the 0 here, I would not exist. But now I can go ahead, cancel these 8s. I can divide that h through. So this changes that to 2, changes that to 1, and gets rid of that. So I now have h squared plus 6h plus 12. And if I get 0 here, that gives me 0 plus 6 times 0 plus 12. And so 12 is my final answer. Alrighty. Continuing here, I'm going to change colors. Okay, over here, this is the one where we have to rationalize the numerator by multiplying by because if I plug a 7 in there, I got a problem right away. So that's kind of the key thing. So again, remember these are terms. So now that means I got the limit as x approaches 7. We have this quotient. So in the top, again, because these are conjugates, I just square the first piece, no middle term, and I get minus 9. In the bottom, I'm going to, I'm going to get x minus 7. And if I FOIL that out, I'm going to get x plus 2. And I'm going to get plus 3x. And then when I do the 7, I'm going to get negative 7x root, or the square root of x plus 2, and then minus 21. Okay. This is minus 7 here. Oh, yeah. So let me undo that here. Didn't have to FOIL that out. Oop. So this becomes x minus 7. I get my x minus 7 here, and then I get the square root of x plus 2, and then plus integer 3. These now cancel. So now I have the limit of x approaching 7. 1 on top with the cancellation of these guys. And in the bottom I have the square root of x plus 2 and then plus 3. And now I can plug in that 7 there. So that's going to give me 7 here, which gives me 9, the square root of 9. Square root of 9 plus 3. That's 3. So I'm going to end up with 1 over 6 for number 17. Okay. So again, these are similar to what Ms. Steele had to offer there. Now this last one here, if I plug in a negative 4, in here, I'm going to be in pretty good shape. Except I got the problem in there wrong. Okay, this is supposed to be a plus. So let me fix that. This is supposed to be a plus. So when I plug in a negative 4, we'll have a problem there. So let's kind of do some simplifying here. Let's see what happens. And we are on number 19. Okay, so I'm going to get the limit. Oops. I'm going to get the limit as x approaches negative 4. I'm going to get a common denominator of 4x here, which is going to give me x plus 4. If I get what okay, and down here I have 4 plus x. Okay. Now, if I go ahead and tip and multiply here, I'm going to get this. I'm going to get x plus 4 over 4x. I'm going to multiply by the reciprocal, so I get 1 over 4 plus x in here. So these cancel. So I get the limit as x approaches negative 4 of 1 over 4x. Okay. And now I can substitute that 4 in there. So I'm going to get 1 over negative 16. Okay. Moving on here, find the limit, and then use a graphing device to confirm your result graphically. Okay, so if I go ahead here and find the limit here, so I'm going to get negative 1 squared minus 1 on the top. I'm going to get well, I'm going to stop here and make another video for the last couple of problems here.